You call me on the telephone, you feel so far away. You tell me to come over, there's some games you wanna play. I'm walking to your house, nobody's home, just me and you and you and me alone. We're just playing hide and seek, it's getting hard to breathe under the sheets with you.
Assalamualaikum and greetings to everyone. Today, we are from Group 5 will present to you about process control. For the introduction, I am Daniel. I will give a general introduction to you. So what is process control? Process control is the active changing of the process based on the results of process monitoring. Once the process monitoring tools have detected an out of control situation, the person responsible for the process makes a change to bring the process back into control. Means that the person or an engineer in charge will bring back the machine or process in the normal condition in order to every machine and process works in good condition. So what is the purpose? The purpose of process control is to keep key process operating parameters within narrow bounds of the reference value or set point.
So today we are going to present to you about transfer function in process control. So there are 5 subtopics that have in our transfer function. The first subtopic is what is the function of transfer function in process control. The second is definition of transfer function. The third is procedure of determining the transfer function. And the fourth is method of obtaining a transfer function. And the last but not least is concept of transfer function. What is the purpose of transfer function in process control? A transfer function represents the relationship between output signal of a control system and input signal for all possible input values. A block diagram is a visualization of the control system which uses blocks to represent the transfer function and arrows which represent the various input and output signal. The cause and effect relationship between the output and input is related to each other through a transfer function. In a Laplace transform, if the input is represented by R's and the output is represented by C, then the transfer function will be like the formula that's shown at the screen right now. That is the transfer function of the system multiplied by the input function give the output function of the system. Definition of transfer function. The transfer function of a control system is defined as the ratio of the Laplace transform of the output variable to Laplace transform of the input variable, assuming all initial conditions to be 0. So in the red box we can see that is the general formula for the transfer function.
Procedure for determining the transfer function of a control system are as follows. First, we form the equations for the system. Now we take the Laplace transform of the system equations, assuming initial conditions as 0. Specify system output and input. And lastly, we take the ratio of the Laplace transform of the output and the Laplace transform of the input, which is the required transfer function. There are 2 methods of obtaining a transfer function. First is block diagram method. It is not convenient to derive a complete transfer function for a complex control system. Therefore, the transfer function of each element of a control system is represented by a block diagram. Block diagram reduction techniques are applied to obtain the desired transfer function. Second is signal flow graphs. The modified form of a block diagram is a signal flow graph. Block diagram gives a pictorial representation of a control system. Signal flow graph further shortens the representation of a control system. Concept of transfer function. The transfer function is generally expressed in Laplace transform, and it is nothing but the relation between input and output of a system. Let us consider a system consists of a series connected resistance R and inductance L across a voltage source V. In this circuit, the current I is the response due to applied voltage as cos. Hence, the voltage and current of the circuit can be considered as input and output of the system respectively. From the circuit, we get V equal to Ri plus L di over dt. And now, applying Laplace transform, and we get this equation. And then we rearrange the equation and we get Gs, which is the transfer function. Gs equal to Is over Vs, which is the ratio of output to input.
So I'm gonna explain about the solution of the question. So given in the question, this transfer function, and then the question also said that the input system equal to unit ramp. So it means that we can obtain two things from this, which are ESS, that stand for steady state error, and also KV, which is velocity error coefficient. So we want to find the ESS, so we need to find KV also.
The formula for velocity coefficient error is given KV equal to limit S to 0 as GS. So from the equation, we put the information given in the question, which is the GS equation, into the formula. So we get limit S to 0, S times 4, 1 plus 2S in a bracket over S to the power of 2 times S plus 2 in a bracket, which represents the GS that is given in the question. So we calculate it. And then we get 0 over 0, which is infinity. So we can conclude that the state error for this question is 1 over kV. The kV is infinity, which 1 over infinity equals to 0. And that's it.